Hello, my name is Vienna Brown and I'm a biologist with the National Feral Swine Damage Management Program. I'd like to start by thanking the conference organizers for the opportunity to present and thanking Dr. Tech in particular for taking the opportunity to record this presentation. So today I'm going to be talking about from monitoring to management, African swine fever preparedness efforts in feral swine. And I need to also acknowledge my co-authors on these efforts. These are all Wildlife Services colleagues, Sarah Bevins, Kim Pepin, Michael Bodenchuk, Dennis Kohler, and Tom Godlewski. And we've also been working in really close partnership with state and federal partners, as well as industry partners on these efforts. So for today's seminar, I'm going to start by providing a background on feral swine and some of the a rough overview of the framework on the APHIS National Feral Swine Damage Management Program. I will walk through national disease surveillance efforts in feral swine, some of the response planning that's been ongoing for African swine fever in the event of an outbreak, some of our research collaborations in specific with Dr. Kim Pepin related to optimal culling radius, and then Wildlife Services response capabilities. So swine were first brought to the US in the 1500s by explorers, and there have been repeated introductions since the first occurrence. In the past 20 to 30 years, feral swine populations and their distribution have expanded greatly. And this is in large part driven by high reproductive rates in these species and a very opportunistic palate. Anthropogenic factors have been huge drivers of feral swine expansion, baiting practices, transportation, and other activities that humans partake in that are driving feral swine populations to new regions. There's also escapees from fenced farming and hunting operations that contribute to feral swine populations, and then breeding on the landscape with free-ranging domestic pigs. There are now believed to be well over 6 million feral swine that can be found across more than 35 states. So both the figure of the maps and the table demonstrate that feral swine populations have expanded drastically over the last 20 to 30 years. Currently, Wildlife Services has operational activities set up in 37 states and 3 territories that are working to remove feral swine. In terms of current feral swine distribution, California and then Texas, Oklahoma, and that whole southeast portion of the United States are heavily invaded with feral swine populations. You can see little pockets here and there, some that are contiguous with larger populations, others that are standalone populations. And again, these can be driven by cross-border movements or anthropogenic movement. Why are feral swine such a problematic species? The truth is there's almost nothing that they don't impact. They heavily cause heavy damage to agriculture with extensive losses. There's almost not a single product that we can find that they do not damage either by direct depredation or stomping on the soil, making it less fertile, or farmers moving away from one specific crop to a different one that is less favorable by feral swine. They cause extensive damage to personal property, extensive damage to golf courses and cemeteries. And then in terms of natural resources, they often outcompete native species. They predate on threatened and endangered species, and they cause extensive damage to very delicate ecosystems. And of course, it cannot be overseen that feral swine pose incredible disease risk to both human and other animals, as well, and in some cases do become somewhat aggressive. So in March of 2014, there was a congressional appropriation where APHIS received $20 million to implement a collaborative nationwide feral swine damage management program in states that were recognized to have a feral swine population. The primary goal is to minimize damage caused by feral swine to protect agriculture and livestock, natural resources, property, and human health and safety. The National Feral Swine Program works to reduce population problems by suppressing populations in states where feral swine populations are large and widely distributed, and working really to focus on reducing damage caused by feral swine. And then the second way we work is by eliminating feral swine in states where populations are newly emerging or there are low numbers. So in terms of the National Feral Swine Program's operational structure, the baseline funding levels are based on population predictions. Level 5 states have the highest perceived feral swine populations, level 1 have the lowest. States that are yellow are found to are in detection status, where they're being closely surveilled for 2 years to determine that feral swine have been eradicated. Level 0 states, which are in gray, are states that have never been identified to have feral swine populations. And then territories, including Guam, Puerto Rico, and the US Virgin Islands, are in the green color. So feral swine national surveillance has been ongoing for nearly a decade. That we have 3 diseases of national concern that we're principally concerned with, which are classical swine fever, which is CSF, swine brucellosis, which is SP, and pseudorabies, which is PRV. We have a congressional mandate to collect a minimum of 2,800 samples annually from feral swine across the US. In the last handful of years, we've had a targeted surveillance approach with samples dispersed over both space and time. And the counties were prioritized based on existing feral swine populations, domestic hog production, and landfills. And this is all antibody-based surveillance, and the outcome of all of these surveillance efforts gives us an apparent seroprevalence. And so the table on the right demonstrates the apparent seroprevalence between fiscal year 2017 through fiscal year 2020, where we see no cases of antibodies for classical swine fever, which is predictable, given that it's a foreign animal disease. For pseudorabies, seroprevalence jumps between about 17.5% and 24%, and swine brucellosis jumps between about 5.5% and 10%. And this is this targeted approach we had from 2017 until 2020. And I will talk briefly about our new and improved surveillance approach that went live at the start of fiscal year 21. So when we look at our nationwide seroprevalence, we see as the color increases, we see the apparent seroprevalence increasing. States that do not have any color no samples were collected, and then the hash marks are for states who have less than 10 samples collected. And then the kind of ivory color is no positive samples. And so when we look across related to apparent seroprevalence, we see that there's kind of every color of the rainbow. We have a number of states that have fairly high seroprevalence for pseudorabies that match what we see at the national scale. But we do see, as the granularity increases, we do see some differences between the states. And again, so for Texas at the state level scale, we see greater than 25% seroprevalence for PRV aggregated for fiscal year 2020. When we break that down further though, and we look at county level granularity, we do see a fair amount of disparate results. And so you can notice that there are plenty of counties that have greater than 25% seroprevalence that are adjacent to or next to counties that have very low seroprevalence or no positive samples identified. And we see that similar trend with swine brucellosis. Overall, the national apparent seroprevalence is lower for swine brucellosis as compared to pseudorabies. Again, we do see states that have higher and lower seroprevalence estimates as compared to the national aggregate. And again, when we look at Texas for the aggregate for fiscal year 2020, we see that the statewide aggregate is between 6 and 10%. And when we look at that more closely at the more granular level, at the county level, we see that very few of the counties actually have that 6 to 10% seroprevalence. We see a number of counties that have much lower seroprevalence or no positive samples identified, and then a handful of counties that have greater than 25% positive. And so again, I think there's a common thinking that feral swine in general are heavily diseased species, which they are. But these diseases are not disseminated equally across the landscape. And as we continue to increase our granularity on those on the data side of things, we see that is the case. In the fall of 2018, African swine fever virus, which had previously been contained to the continent of Africa and Eastern Europe, made some pretty substantial global jumps, showing up in Western Europe and Southeast China, which then spread quickly to Southeast Asia. And so APHIS became quickly very concerned about that. And ever since that time, APHIS has been heavily involved in preparedness and control efforts for African swine fever in both domestic and feral swine. In response to that, Wildlife Services rolled out a morbidity mortality surveillance effort for African swine fever and feral swine. This was rolled out during fiscal year 19. And we are asking our biologists to look for evidence of sick and dead feral swine in the landscape, and in specific, those animals that have inexplicably died. And so these, in the cases where the trigger is tripped as a foreign animal disease or morbidity mortality surveillance effort, these animals then triage up through veterinary services as part of a foreign animal disease investigation. So our biologists and state directors are working in close partnership with their area veterinarian in charge at veterinary services, and that person has the ultimate authority on whether that sample is worked up as a full foreign animal disease investigation event, or if they feel comfortable that either the clinical disease or the death is unrelated to a foreign animal disease outbreak event. In the last 2 years that the surveillance has been ongoing, there have been 11 cases reported in 7 different states. Of those 11 cases, 5 of them were deemed inappropriate to move forward as a foreign animal disease investigation. The other 6 were all worked up as a part of foreign animal disease investigations, and they all came back negative for both classical swine fever and African swine fever. I want to walk you briefly through a quick case study based on the African swine fever surveillance efforts. This really demonstrates how Wildlife Services is approaching this issue, and then also demonstrates the networking that Wildlife Services biologists have with their both with their Wildlife Services leadership as well as their counterparts on veterinary services and their state agencies. So this was an animal that was a lone boar that was found in extremely poor body condition with a hoof lesion on the right front limb in Mississippi in April of 2020. Our field biologists, we'd recently done some training related to these foreign animal diseases, and our biologists recognized this as something that was would trip the trigger as a unique case, thinking about foot and mouth disease in specific. And so he contacted both his state director and headquarters staff from both the National Feral Swine Programs and the National Wildlife Disease Program, and also contacted the Veterinary Services area veterinarian in charge and sent a photo. After further investigation, the animal was found to have an embedded constricted band of plastic around the hoof, which was responsible for this lesion that was seen. And the ABIC decided not to send samples forward for this animal as a part of a foreign animal disease investigation. But the carcass was incinerated at Mississippi State University Diagnostic Lab as an additional layer of protection. And so you can see here that the communication between the different agencies is fluid. We work really, really closely with our partners and really focus on having these streamlined communications. So we have these working relationships, and we're not trying to create new relationships or build bridges when we're in a time of crisis. At the start of fiscal year 2021, we rolled out a new national feral swine surveillance metric. This is really predicated as a foreign animal disease surveillance system. It's especially focused on classical swine fever, African swine fever, and foot and mouth disease. For our surveillance approach, we will continue to be doing active surveillance for classical swine fever, such that our field biologists are collecting blood samples, spitting those down, and we are sending serum on to the Foreign Animal Disease Diagnostic Laboratory at Plum Island for antibody testing. Our morbidity mortality surveillance will continue for African swine fever, such that we are not sampling apparently healthy animals for evidence of African swine fever. However, we will continue to be on the lookout for any of these of morbidity and mortality events and work those up with our partners as appropriate. And then we have started active observational surveillance for foot and mouth disease. We're asking our biologists to take a quick look in the mouth, along the snout, the gums, the tongue, and the hooves of each of the animals that they are sampling for national surveillance, and check a box if they do not see any evidence of vesicular lesions, check a box if they do not. If they do, these animals will also be triaged through veterinary services as a part of foreign animal disease workup events. The risk factors that are driving this are twofold. The first is risk of introduction, and that is driven by data that is coming out of PPQ and Customs and Border Protection related to airline passenger cargo data. So we have information on products that are confiscated, where the person was originated, where the person was destined, where the product was confiscated, and we can extrapolate that data up at a larger scale. And so, for example, if we have a passenger that originates in Hanoi, Vietnam, is traveling to Lincoln, Nebraska via LAX with, say, some sort of pork product that is illegally confiscated, we know that the actual risk, had it not been confiscated, would have been in Lincoln, Nebraska. And so we can use that data to drive these risks of introduction. Of course, landfills are potentially risky in terms of introduction and as well as seaports of entry. In terms of host risks, domestic livestock populations are driving some of these risks. For FMD, we're using just information related to all domestic livestock production, less poultry. And then for ASF and CSF, we're primarily concerned with domestic swine production. And then feral swine populations are also being used to drive some of these host risk factors. What's really, really handy about this is that it can be easily updated to address emerging threats. And so as countries either become endemic with new diseases or countries are able to eradicate diseases, any of these foreign animal diseases, we can update our modeling approach accordingly. We are continuing to monitor for production diseases, both pseudorabies and swine brucellosis. However, we are not, we are piggybacking SB and PRV surveillance on the back of this foreign animal disease approach. And we are not using PRV or SB to drive any of the targeting. We have also increased our sample size nearly twofold to nearly 6,000 animals annually. And that gets us down right around a 1% detection rate for classical swine fever, which of course is the OIE standard for surveillance. And so that kind of wraps up our overall national disease surveillance system in peacetime, if you will. And I want to begin to walk you guys through some of the response planning for African swine fever and how we're approaching this and thinking about it from Wildlife Services. So when we think about controlling efforts for ASF in feral swine, the first big thing is detecting the virus in the landscape. And so as we work in close partnership with veterinary services and other state agencies, this is very, very different than detecting a pathogen in domestic populations. It would be likely that there would be an extensive lag between an introduction event and an actual detection event, carcasses between scavenging and environmental factors, and just the remote location. Carcasses in the landscape are not that easy to find, and we've seen that time and time again with chronic wasting disease, where we'll have prevalence up in the 25 or 30%, but we don't see carcasses all over on the landscape. So we can anticipate something like that, even though African swine fever virus has an exceptionally high mortality rate. It wouldn't be anticipated that it would be necessarily super readily detectable. Carcass-based transmission is really important. We've seen in the European Union examples, carcasses staying on the landscape often serve as a vessel for continued transmission. And so getting those carcasses moved off the landscape would be really, really important, both animals that are being targeted as a part of removal efforts and those that die from the actual infection. Diagnostic testing of carcasses and of feral swine removed would be an important logistic that we're currently working through in terms of where to do that, how to do that, laboratory capacity, and all of that in terms of what sample types would be needed and our ability to get those shipped quickly. And again, carcass removal and carcass disposal, which are things that we don't often think about from Wildlife Services perspective, because most of our operational activities, we leave those carcasses on the landscape. And so as a part of our partnership with veterinary services, we have worked up a feral swine response framework within the African swine fever response plan, the Red Book, which is kind of the Bible, if you will, for foreign animal disease response efforts. There are issues that are associated with foreign animal disease outbreak in feral swine that again do not show up in domestic swine or other domestic livestock outbreak events. So controlling and managing population of free-ranging species is very difficult. And of course, the possibility for spillover and spillback dynamics between feral swine and domestic swine really, really complicates eradication. And often really basic data is lacking in wildlife species. So even things related to, sounder interaction or the details on population estimates and movement, oftentimes it's really, really basic data is a black box for feral and wildlife species. And so as we're thinking about this, our current Red Book recommendations are built around establishing an infected zone surrounding an ASF positive carcass, plus 2 to 3 times the home range size. We do have GPS collar data that is giving us some good estimates on home range size in feral swine, although it is important to recognize that home range estimates do vary quite drastically by location and available resources. So in working through the GPS collar data, it looks like the average monthly home range is about 3.4 kilometers squared, and that gives us a corresponding radius of about 1 kilometer. We want 2 to 3 times that for the infected zone, and that gives us an infected zone radius of 3 kilometers. It is important to note that especially for lone boars, we do see larger movements ranging anywhere from 1 kilometer squared to upwards of 60 kilometers squared, which of course increases our corresponding radius. Importantly, and thankfully, contact is uncommon between feral swine that are more than 2 kilometers apart on the landscape. So this is what is currently in the ASF Red Book for feral swine response. In the left graphic, the one little white X is our infected, one infected pig. The pink zone is the infected zone, that's our 3 kilometers. Outside of the infected zone is a teal zone, that's a buffer zone, that's another 2 kilometers. And the infected zone and the buffer zone, which are a total of 5 kilometers, are our control area. On the outside of the control area, we have a 5 kilometer surveillance zone. So this would be a total of 10 kilometers for of a management area for each event. It is important to note in the right graphic that you see, it would be unlikely, of course, that we'd find a single infected animal. And so the 10 kilometer radius is dynamic and continues to move out with each carcass that is found. It would be 3 kilometers, 2 kilometers, and 5 kilometers from the furthest out carcass. So it might not even end up being a circle at all at the end. But that's the feral swine management zone that we'd be looking at. Excuse me. In terms of management actions, in the event of an ASF detection in feral swine, our first activity would be putting an area of control in place and really wanting to do some recon related to determine the extent of the spread. And again, as I mentioned, we would adjust the area of control to encompass all positive animals. This is a really, really important activity. We've seen in other countries in the European Union, which would be probably most closely related to what we could anticipate in the United States, that this disease just tends to kind of blow up and march across the continent quite readily. And so understanding the epidemiology of the pathogen on the landscape, understanding where animals are and are not infected, understanding the biology of these animals, the ecology, it is really paramount to getting a handle on the virus. As I mentioned, carcass detection and removal is also paramount. It has been demonstrated in Europe that upwards of 50% of all ASF transmission in wild boar is carcass-based and carcass-driven. So finding infected carcasses on the landscape and getting them removed is really, really paramount to a successful outbreak management. Feral swine population reduction, of course, is also really important. This disease is density dependent to some degree, so bringing that susceptible population down is really important for managing the disease in the landscape. And then testing those animals, especially as you think you're winding down on an outbreak event, figuring out what animals are and are not infected and have been and have not been exposed is really important. So in general, our overall approach, we're using home range estimates to determine the infected size zone. We're wanting to use the minimum radius necessary. It needs to be large enough to encompass the outbreak event, but we're wanting to keep it as small as possible. It makes it more manageable. On the ground surveillance using both individuals walking transects. Clearly, I'm a lifetime student. Individuals walking transects, the potential of using drones, aerial surveillance, and then we also have detector dogs that could be utilized to help locate carcasses on the landscape and get a feel for where the outbreak is operating. We can also use additional location-specific data if available. And then one of the big things as we are approaching this is thinking about the balance of wanting to have a a control area that is large enough to encompass the risk, but not so large that it is either terribly conservative or just becomes totally unwieldy. Another big thing that we're thinking through are some of the research questions, and one of those is optimal culling radius. And so we're currently working under the 325 kilometer radius for infected, buffer, and surveillance zone, respectively. But we've also partnered with Dr. Kim Pepin out of the National Wildlife Research Center to look at that optimal culling radius from a little bit more of a rigorous perspective. So as I mentioned, our Red Book approach, in the greenish graphic on the left, we have a detection event in feral swine. We have an infected zone, which is 3 kilometers, a buffer zone, which is 2 kilometers, and a surveillance zone, which is 5 kilometers, for an overall feral swine management zone of 10 kilometers around any given carcass. When we think about this optimal culling radius, we're really looking to optimize this. And so when we think about optimal, we're looking at the absolute smallest radius to reach elimination with the least amount of culling necessary and the least amount of African swine fever transmission. And we're also interested in whether it makes more sense to cull animals starting from the inside and work out, or from the outside and work in. And Dr. Pepin is helping us answer these very important questions. So when we think about, from a methodological standpoint, we're introducing a case in the landscape with X density of swine, feral swine, and we're simulating the spread of African swine fever virus across the landscape. So in this case, for this example, we're initiating culling on day 25, which is our first day of detection, and we're going to continue culling those animals until the virus is believed to be eliminated. This kicks out the total number of ASF cases, the total number of animals that need to be culled, the area of the outbreak spread, and the duration of the outbreak. And the minimum of those 4 factors is what we're calling the optimal metric. So the conditions that we're able to vary are feral swine densities, low, moderate, and high, the day of initial detection since introduction. So again, because we're working with a feral or wild population, there's going to be a lag between when the virus is introduced on the landscape and when it's detected. We currently have that set up as 30, 60, 90, or 120 days. It could be shorter than that, could be longer than that. But of course, the longer that lag time is, the bigger the outbreak. We're also working with our state directors and other operational elements related to the culling capacity. So the proportion of pigs that could be removed per day in a culling area. And that can vary anywhere between 0.5% and 30%. And this, of course, is heavily driven by the region that we're operating in, the time of year, and the technique that we're using. We also have extensive GPS collar data from both Florida and South Carolina. And so we can use those local conditions to provide increased granularity related to movement and contact of feral swine in those various ecological settings. And so Dr. Pepin has basically worked this up as an Excel app that spits out the optimal culling radius based on those 4 factors, so detection time, feral swine density, culling capacity, and local ecology. The second thing we're working on is a planning tool it's early in development, but related to culling capacity based on local ecology. We fully recognize that different tools are needed in different conditions, and different tools vary by efficiency across conditions. And so this allows us to ask the question of what culling capacity is needed to reach elimination within a particular time frame under different local conditions. This allows for ease of planning related to transfer of equipment and supplies, as well as the mobilization of personnel and equipment. And so when we think about Wildlife Services response capabilities, Wildlife Services has a number of different tools that we use as a part of our normal operational activities. We have these activities that are ongoing across all of the US every day. And so we will be pulling from the same toolbox as we think about how Wildlife Services would respond to a specific event. It is important to note that we've been exceptionally mindful about not painting ourselves into a corner related to exactly how we would respond, just because environmental conditions, feral swine densities, time of year, geographical features, all of those are intimately intertwined with how we would respond and what would be an efficient metric and method to use at that time. And so we have really just been intentional about focusing on this is what Wildlife Services could do. And in the event of an outbreak event, this is, we were pulling from that toolbox. So in terms of surveillance, we have camera, trail cam, and accessibility of drones, as well as I mentioned scat dogs, carcass detecting dogs. We also have our aerial operations, depending on the time of year, live traps, both the real, the advanced models with real-time cameras and remote trap door closure, as well as more old school models that would be appropriate in really remote conditions. We have snares, and in low density areas, it may be appropriate to work with Judas pigs or decoy pigs. Also the possibility of fencing, depending on the geography and the size of the outbreak, and then sharpshooting. And again, we'd be pulling from this set of tools in the event of an outbreak event. And I just want to reiterate that this has been an extensively collaborative effort. Wildlife Services, headquarters staff from both the National Feral Swine Program and the National Wildlife Disease Programs have been intimately involved in this. The researchers from the National Wildlife Research Center are answering questions that have a heavy research background. And the Wildlife Services operations has also been instrumental in gathering data necessary to drive these research questions, and then also their participation and buy-in in the event of an outbreak event. We're also working in close partnership with veterinary services, National Preparedness and Incident Coordination, working through logistics around data sheet and database management. We're working with our swine health staff partners, and then the Center for Epidemiology and Animal Health. And these are really big questions and have tremendous implications for domestic swine movement, international trade, and have huge impacts for the domestic swine industry. And so we are working in close partnership with all the appropriate parties to make sure that we're all working towards the same end goal at the same pace. And with that, I'd be happy to take any questions, or feel free to send me an email at vienna.r.brown@usda.gov. Thank you for your attention.